Hi, calc class, and welcome to Chapter 2. This chapter is all about functions. We're looking at domains, ranges, vertical line tests, those type of things, your input and your output. So you should have Chapter 2 notes in front of you. We're doing properties of functions, Section 1. And let's go. All right. First, we're going to recognize the function with a vertical line test. Remember, that's when if the vertical line hits the function in only one place, then it is a function. Which didn't make sense. If it hits the relation in only one place, then it is a function. Domain and the range, remember the domain is the x and the range is the y. Let's get to my pins here. So domain is x, range is y. We're going to evaluate functions, so we're going to give them values. And we're going to determine if they're even or odd. So first is a vertical line test. Remember, in a vertical line test, that means every x value has exactly one y value. Remember, domain means x values, range are the y values. So let's see if you remember. Is it a function, yes or no, and why? Pause and try it. All right, x squared, I'm hoping you remember this is a yes. The domain is any x value, so it doesn't matter, it's positive, negative, so it's negative infinity to positive infinity. No matter what value for x you plug in, you get exactly one y. I know there are more than one y values that match, but they come from different x's. So the answer is yes. X maps to 1y is how you say that. Okay, square root function. I'm hoping you said no. And the reason is that an x value can map to more than one y. So for an example, if x is 1, then y is -1 or +1. So x has more than one value, therefore not a function. This last one should have also been no. You should have said 28 maps to 19 and 27, which is bad. So therefore not a function. Okay, vertical line test. If you draw a vertical line, it means the same thing. So the vertical line represents the x value. It can only hit the function once, otherwise, because that represents the y value. If it hits it more than once, then it is bad. So graph and explore, see if you can get it. So here, your x squared is your parabola. When you draw every vertical line, no matter where you draw it, you will only hit the parabola once. So the answer is yes. Passes the vertical line. Every x has one y. Okay, this one here is the square root. So I hope you remember the positive square root goes up like so, and the negative square root goes down like so. So this word, the answer is no. If I draw let's just draw one here. Okay, why did that disappear? It hits it at 2 spots. Therefore, the answer is no for an example. So, not every x has one y value. And an example would be x equals 1, then y equals -1 or 1, which is bad. So it has 2 values. Okay, unless otherwise stated, assume the domain of all functions defined by an equation is the greatest subset of real numbers that meaningfully replace for the independent variable. What does that mean? So that means that your domain are the x values that have meaning. An example would be just the one we just did with the square root. The x values only have meaning from 0 and above. So your domain is 0 to infinity. The range are the y values that have meaning. Or a value, however you would like to state it. All right, I would like you to do these. Pause and try them. What's the domain and what is the range? If you look at this one, the domain Remember, that's the x value. So it starts at -1 and ends at 4. It is inclusive, so we use the brackets. So it's -1 to 4. The range, remember that's what the y value is. So the y value starts here, because that's the first place it has a value, ends at 3. It is also inclusive, so it goes from 0 to 3 with the bracket. Y equals 7. Well, if y equals 7, x can be anything. So that is -infinity to +infinity. And if y can only equal 7, then your answer is it is 7. And that's all you get. Okay, the domain is this. So I'm giving you the domain. I would like you to tell me the range. So the range now is a set of points. When -2 is squared, it's 4. So this one's 4, 1, 0, 1, and 4. So then my set includes, we only list the elements 1, 0, 1, and 4 are the elements of the range, our domain, I'm sorry. When you're inside here, you know that your x value, it has to be greater than 0 or equal to. So when you set this equal, you go, all right, so 6 minus x has to be greater than or equal to 0. Let's add the x over. So 6 has to be greater than or equal to x, or x has to be less than or equal to 6 in order for this to work. So my domain is x is less than or equal to 6. And then if you realize this, that means the y is only positive because I have no plus or minus out front here. So since the y is positive, we are going from 0 to infinity for the y value. This one's a little bit different. Here, we cannot divide by 0. So this value on the bottom has to be greater than 0. And it also has to be greater than 0 on the inside. So we go x squared minus 4 has to be greater than 0, which means it has to be positive. Well, if you remember from your number lines, this is x plus 2, x minus 2, greater than 0. Now you're checking. So -2 and 2. Plug in the numbers to see if they are true or false. So we'll pick -3, 0, and 3. I plug in -3. I have a negative times a negative, which is positive, so that checks. I plug in 0. We have a positive times a negative, which is negative, so that does not check. Plug in 3 is a positive times a positive, which checks. So in other words, I have to be from -infinity to -2, and from 2 to positive infinity is my domain. So we're going to go from -infinity to -2. It cannot equal -2 because that's 0. And the same with 2, it cannot equal 2. Now, when we look at this, we also know that there's no way that y can be negative because that's not possible for the bottom number. So since it is not negative, it has to be from 0 to infinity. Okay, let's go. This is just showing you how something maps. You take the value from the x, you plug it into the function, and you get the y value. So you take the x, you plug it into what you have, and the answer is the y. What you plug in is your domain. So I want to find g of 3. So I'm asking you what 3 maps to in the y. So this is a point. If I plug in 3, I plug it in for all the x's up here. So we have -9 plus 12. Remember the negatives on the outside. Minus 5. So we get -2. So my point is 3, -2. So 3 maps to -2 is how you would read that if you were doing it in this order. Okay, pause and do yours. You're using the same g function as above. So the first thing you do is you plug in the a. So you have -a squared plus 4a minus 5. Plug in the a plus b. This is a plus b quantity squared plus 4 times a plus b minus 5. Should probably practice doing that distribution just so we don't forget. So that's a squared plus 2ab plus b squared plus 4a plus 4, oops, I forgot my 4, minus 5. Distribute your negative. Forgot my parentheses. So that's -a squared minus 2ab minus b squared plus 4a plus 4b minus 5. Nothing combined, so you are done. All right, now let's look at the x over 2, or the 2 over x, I'm sorry. So now you do minus 2 over x quantity squared plus 4 times 2 over x minus 5. Square all this, so we have minus 4 over x squared plus 8 over x minus 5. And that is g of 2 of x. Not too bad, right? At least we don't have to graph them yet. That's coming. Even or odd? Even or odd, if you remember from pre-calc, is where you just plug in negative x. If you get the same function that you start with, it is even. If it's the opposite function, it is odd. If it's neither one of those two, then it's neither. Example, this is my function. I take out the x's and I plug in negative x. My resultant function is exactly the same as my original, so therefore it is even. Pause and try yours. All right, when you plugged in the negative here, so you're finding f of negative x, you get negative x cubed plus a negative x, which is equal to negative x cubed minus x. It is exactly opposite, so this guy is odd. Okay, let's try it down here. F of negative x, be careful with this one. So you plug in a negative x here, and when you plug in the negative x here, remember it goes inside the parentheses. So technically you have negative x over x squared minus 3. The denominator stayed the same, the numerator changed, so this went from a positive function to a negative function. It is exactly opposite, which makes it odd. I know that's weird, right? But remember, 1/2 is positive and negative 1/2 is negative. These are exactly opposite. This is the exact same thing, so this is odd. Last but not least, so we have negative x squared plus negative x minus 5, which gives us x squared minus x minus 5. Well, this stayed the same, but the x changed sign, so it's neither even nor odd since both of them happened. So this guy is neither even or odd. All right, let's keep on moving. Piecewise function. Remember, that's when you have more than one thing. So all we do here is we plug it into the section we're supposed to. So this here says it can't be equal to 4, and this says it can be equal to 4. Remember, this is your domain. Whoops. Sorry about that. All right. So now if I have f of 5, so I look at my domain, 5 fits here, so I plug it into the top equation. So this is 2 times 5 plus 1 over 5 minus 4, and we get 11. Okay, try your 2. I hope you recognize when you had 4, you were on this function, so the answer is just 7. There's no x in that problem. Negative 3 would again fall on the top one, so you would have done 2 times negative 3 plus 1 over negative 3 minus 4, which gave you negative 5 over negative 7, or 5/7. The trick there is to watch your domains. All right, this is a piecewise function. I'd really like you to pause and give it a shot just to see how you do. All right, why are the points not connected? And the reason is it increases $3 every pound. It doesn't allow for fractional increases. So it increases $3 at the pound. All right, so now let's create an equation. When I look at this, I know I start at 25, but this guy is really weird because this one right here is longer than all of these. Because of that, I truly have a piecewise function. And the first step is, you need more room here. So y is equal, and the first one is going to be 25 if x is between, so it's going to be greater than 0. I just wrote that backwards. Sorry about that. All right, let's try that again. So I know 0 is less than x, and x is less than or equal to 2, because that's where my closed dot is. Now when I look at my function, I had to figure out where this dude is starting. So I'm hoping you recognize that this is a step graph, and that's actually the bottom graph, remember? All right, I'm going to start at 2, positive 2. So that means I'm going to put x minus 2 in here because I'm shifting over plus 2. Remember, left and right moves, your transformations. I'm going to go up to 28. So the y is plus 28. And then this jumps 3 every time. So I have to put a 3 in front. I know that's a little difficult. I just wanted to see if you could think. I don't think the ones on your homework are that hard. They're a little bit easier, in other words. Good luck, and I hope you do well. Remember to post questions and to help each other out.